Hello guys, welcome to this channel. And starting from today, we will be introducing a series of videos which focuses on explaining some very important topics and subjects for your daily structure design and calculations or for your PE or SE exam problem reviews. If you are trying to get your license, I hope those videos could be very helpful with either your review of the PSE exam or your design work. All right. So next, please allow me to do a very simple, quick self-introduction. My name is Sean, and I am a licensed engineer here in the United States. I've been working in civil engineering industry for almost 12 years, and my work spans over many areas like residential and commercial buildings, industrial plants, high rises, infrastructures, and heavy civil jobs. I passed the exam and became a PE in 2018. At that time, we still have the paper and pencil version of the PE exam, which is 8-hour exam from morning to evening, no electronics allowed, and only carry your books and notes with you. Right, I still remember the first time I took a full size check-in luggage to the exam, full of books and heavy as hell. And someone even pulled a small cargo cart full of books too to the exam. So, just for reference, you can imagine how many books and papers you need to carry in order to pass the exam. But right now, if I recall the whole procedure, I still treat it like it's hard, but it's a fun experience for the PE exam. All right, in 2021, I finally got my SE exam passed, building sections. And compared to PE exam, SE structural engineer exam, in my opinion, it's just a different ball game. 2 days, two super hard sections, 16 hours total, pencil and paper, limited test location due to the pandemic. So many aspects are contributing in this exam and make the SE exam so hard to pass. And it cost me 2 years, two exam takes, maybe more than that, in order to pass the exam. So if you have the plan to get your own license, or even more, get your SE certificate, building up the good foundation will definitely be the right choice. That's what exactly we're doing from today, from now. All right. So let's start the game here. So today we'll be introducing with the first topics, and you already see it right here. So it's the tributary areas calculations for one-way slab. All right, why this topic? Tributary area calculations and the one-way slab are the most fundamental concepts in structural engineer design when we're trying to do a load calculations. So as long as we can figure it out, first, if the slab is a one-way or two-way slab, and number two, what is the tributary area of each structure components? If each structure component in one-way slab system or two-way slab system, then the total loads transferred to each component will be calculated out much easier. All right, so let's move on to the first concept. Right now, I want to do a little bit order adjustment. So we'll do the one-way slab first. All right, first concept. What is a one-way slab? By definition, right here, you can see it. So if the slab panel has an aspect ratio greater than 2, the slab weight is supported by two longer boundary members. What that mean? Actually, I already have the structure drawn up. Let's see some examples. So you can see this is we can call it a building. Let's define some structure members we're going to use for this example. All right, so the horizontal one we call a beam. So every single horizontal structure members we can call a beam. And the vertical one, which is different colors, orange one, we call it girders. And the green one right here around the corner, we all know about it. We call it columns. And between each beam and a girder, there are also this part. Even though it's not shown on the drawing, but we all know this is a slab. So I can rename every single structure. Then you can be girder. Right beam. And then column. All right, so that's all the structure members we have for this example. All right, let's go back to the definition of the one-way slab. What is one-way slab? What do you mean aspect ratio greater than 2? So in this case, we can see we'll put a 40 feet as a beam length. We call it L. L equals 40 feet. And you can see for certain spacing, the beam is repeatable. And the spacing, beam spacing, we call it A. In this case, I believe it's 10 feet, but let's confirm it. Oh, right, yes, we have a 10 feet as beam spacing. So in this case, you can see, oh, right, if this part is a slab, we need to figure out, okay, is that a one-way slab or two-way slab? Then you can see that clearly this is one-way slab. Why? Because the slab is supported by 1, 2, 3, 4 members. And you can probably already notice that there are 2 longer members and there are 2 shorter members on this side. And by definition, the longer member, which is 40 feet, is greater than 2 times the shorter members, which is the truth because the shorter member is only 10 feet. So 2 times 10 feet is 20 feet. So 40 feet definitely over 20 feet. So by definition, the slab right here will be our one-way slab. All right. So after this, I believe everybody know what is a one-way slab. Why? All right. I believe everybody should be knowing what is a one-way slab right now. And then let's move on to the next concept. What is the tributary area? There's a lot of definition out there. All right. And someone might be very confusing. I'm not sure, but I will let you know what I'm thinking. Tributary area, we can think about something very simple. All right. It's like you go out with your friends. You want to share the bill, right? And you don't want to be sharing an uncertain amount of the money. You guys already have a general guideline how much you should pay. For the most cases, you split the bill by half. For example, the whole bill is $100 and you guys decided, okay, I pay 50, you pay 50, or make it even. All right. Actually, the definition right here is exactly what we're gonna do for the one-way slab tributary area calculations guideline. All right. For example, we have this beam number and it's on the edge. We can imagine the slab right here in purple color, right here. The slab right here is the bill. All right. And the beam between columns number 1 and 2 only share the bill with beam. Maybe we can call it numbers. That would be much easier. Yeah. So we can call this beam number 1. This guy, beam number 2. So you can see the column, the slabs between the beam number 1 and number 2 is like the bill. And the beam number 1 and number 2 want to split the bill evenly. So the beam number 1 taken half. And beam number 2 take another half. So just that simple. All right, so you can imagine, okay, Sean, what about this bad guy? between the column 7 and column 8. Apparently, he doesn't have one bill. Doesn't only have a one bill. He might be two. What are you going to do here? It's the same concept. It depends on how many bills he's sharing, how many members, or in that case, how many slabs he shared with the different members. All right, so we name it beam number 3. This is beam number 4, beam number 5. Apparently, beam number 3 is sharing more because he went out with beam number 4, and then maybe 1 hour later, beam number 3 went out with beam number 5. So beam number 3 have 2 bills. But no matter how many bills that he has, he always split the bill by half with the different friends. For example, he shared the half right here with beam number 4. Then shared another half here. Of course, different bills with the beam number 5. So that's his totally tributary area right here for beam number 3. So in this case, we can calculate it how much exactly the tributary areas for beam number 1 or beam number 3. All right, for beam number 1, we already talked about it. This is a 10 feet, so that's the 10 feet. What's the length of the beam? That's a 40. So for beam number 1, the whole tributary area will be 40 feet times half times 10 feet, because it's shared with the 10 feet with the beam number right here, number 2, remember? So that will be the whole thing for beam number 1. What about beam number 3? Same thing here. This is 5 feet because this is 10. This is another 5 feet. And it's the same length. So the tributary area for beam number 3 will be 40 feet times 2. There are 2 times half of the 10 feet. Which, oh, I'm sorry, didn't finish the calculation right here. This is 200 square foot. And this is a 400 square foot. All right, just simple like that. Just imagine you have the friend, you need to split the bill evenly between them. And then that's your tributary area. And you might have another questions like, okay, Sean, I know, I got you right now. Then, like, that's only the beam. What about the girders? Apparently, girders carry a lot of weight, like maybe a lot of tributary area than the beams, since a lot of beams are landing on the girders. Actually, in one-way slab, we can still do the same game or the same theory for the girder beams. All right. So, for example, the girders always have us, and also the girder have two same situation with the beam. One is on the edge, like this one. The girder is on the edge, so it's only share the half. And the girder is in the interior, they're gonna share with the two. But always find their friends to share the whole thing. For example, the girder between column number 6 and 12, which is another color, sorry. Right here. We call it girder number 1. And this is called the girder number 2. So this part, you always find the same components they can share the bill with. You're not gonna share something with a beam because it's different components. So this is a girder, and this is a girder, and if they are next to each other, and they also carry and sharing the slab, and then that's the distribution comes from. So in the same theory, we're gonna divide by the slab area into 2 parts and evenly distribute it into 1 and 2. So girder number 1 taking half of this part of a slab, and another half belongs to girder number 2. All right, that's the edge beam. So, I'm sorry, edge girder. What about the interior girder? Same concept. Because exactly like the beam, the girder already have two friends next to him, right here and right here. So this is number 3, 4, and 5. So you can already see it. This is exactly the same theory about a beam. Girder number 3 shared a half with the girder number 4, and shared another half with girder number 5. As long as we can figure out, okay, what's the spacing is the girder, how far is the girder number 3 to 5 and 4, then we can figure it out easily to do the tributary area for girder number 3. All right. So in this case, let's do the final calculations. So the length of the girders is going to be 10 feet right here times 3, going to be 30 feet. I'm still going to write in. I just probably don't want to confuse you guys. That's the length. What is the width? Apparently, that's a beam. That's a half of the beam width. It will be 40. Right? In other words, it's going to be 30 feet times 20 feet. It's 600 square foot. All right? That's the total tributary areas for girder number 1. What about the girder number 3? Similar. Actually, in that case, I can give you the answer right now because we're having this equal length of the beam. We have the spacing equally between each girders and also the beam as well. So basically, you can see, and you already know probably, that's the 2 times 600 feet because the interior girder tributary area of the interior girder is 2 times the edge one. All right. So for number 3, girder number 3, that'll be 1,200 square foot. All right. So we already finished 2 of them. Then we have a 1 way down there to go. So what about the column? Actually, column is a little bit complicated, but it's still going to be the same concept. Let's do another chart again. Erase this part, this part, this part. Let's leave this part. Change another color. Green one is good. All right. So you can see for the columns, we have 3 different situations. One is a lonely guy. He is only the corner guy, and he doesn't have a lot of friends, right? And this one apparently is more central. He had more friends, had more connection. And here is the party star, column 11. He has way more than the other 2 guys we introduced before. He has more friends there. So how to tell? What is the responsibility or what is the bill for 13, column number 13, 15, and 11? Remember, we call the same concept. Figure out what's the slab the components is carrying, and how many members other than the column number 13 is sharing the load with number 13. Okay, so if that's the case, let's do that. And also, the load, the tributary area need to be figured out in the same definition of the components members. For example, if you share the tributary areas with beams, and then you need to find out the beams, which is the closest beam, the next beam next to the structured components, you'll try to calculate it. For the girders, you always want to find the girders, not comparing the girders to the beam to the girders, unless you are introducing something else. But in one-way slab, that will be the only definition right there. So for the columns, you always want to compare with different columns, not the columns of girders and girder to or columns to the beams. All right. So in that saying, we only need to find what's his neighbors or friends right here. So in this case, column number 13 only taking care of the 1/4 is a quarter of this whole bill right here. How about the edge column number 15? We can treat it as a two bill. We treated the situation like two bills. This is the first one, which is a quarter, right? And another one right here is also a quarter. And quarter plus quarter is 1/2. That will be the bill number 15 need to be need to be paid. And then what is number 11? Column number 11, he's stuck inside, he's a party boy. But it's still going to be the same way. We divide by the area of the slab into small portion and calculated each portion how much was the percentage the interior column number 11 need to be taken care of. So this is a quarter, this is another quarter, this is another quarter, and this is another quarter. All right, so if that the whole like each slab is evenly distributed is equal to another one, that will be the whole slab area. It was 1. That's a quarter times 4. So that's 1. So in that case, then we can calculate that what's exactly the tributary areas for each column. For example, column 13. That will be 40 feet, which is the length of the beam, times half. And times, that's 10, 10, 10, 30 by half. So the tributary areas for column number 13 will be 300 square foot. All right. So for column number 15, right here, then we can calculate like this. This is still 40 times half, but the length doubles times 2. It's the same width right here with the column number 13, which is the same half of the 30 feet. So no doubt that will be 600 square foot right here, all right? And then what about this party boy? In theory, because this is a half, this is a 1, so we can guess this is 1,200 square foot in total. But let's test out the theory. That's going to be the true or not. All right, let's do it. So this one is a 40 by half, so it's going to be the same thing. 40 times half times 2, because in 2 parts, and it's the same thing for the width too. So width will be 30 times half. Oh, I didn't write it. Sorry. 30 feet times half times 2. So exactly, that's 1,200 square footage. Exactly like we said before. All right. So that's all the material and the concept and calculation method we need to introduce today. So let's go over the whole concept very quick. One-way slab, what's the definition of a one-way slab? Is the boundary numbers have a 2 longer one, 2 shorter one. If the longer boundary numbers, the length of the longer boundary numbers is over 2 times of the shorter one, then we call this slab, supported by the 4 members, will be the one-way slab. All right? As long as we figure out one-way slab, and then we already know how to calculate the tributary areas for each beams, girders, or the columns right here. So please remember, we always play the split the bill game between the same structure components. The beam need to be shared the whole thing with beam. Girder need to be shared with the girders. Columns need to be compared with the columns. We don't mix match it with the different structural components. But as long as we can figure out, okay, what's the structural components, what's next to them, and then we can figure out the tributary area very easy. All right, and that's it. So please leave the comments below if you have any questions. Let me know, and I will read the comments. I will do my best to answer each one of them. No matter is a definition, detail explained, whatever it is, or just quick inquiry about this PE or SE exam, I will be very pleased to answer them all. Alright, if you like this video, please subscribe this channel and click the thumb up of this video, and I will see you in the next episode. Thank you so much. Bye.